You slide into a hotel bed and your eyes snap open. The mattress is wrong. The pillow is wrong. The darkness tastes different. You've been lying there for 2 hours and your brain won't let you slip away. But you're exhausted. You know you need sleep. So why won't it come? The answer isn't laziness or anxiety, though those don't help. The answer is that your brain is doing exactly what it evolved to do, and it won't stop until it feels safe. Every animal sleeps, but not every animal can fall asleep anywhere. Your brain has a built-in security system. It runs 24 hours a day. When you close your eyes at home, that system relaxes because your brain has mapped every sound, every smell, every threat in that space. It knows which sounds mean danger and which ones mean the refrigerator. But in an unfamiliar place, your brain is back on high alert. Researchers call this the first-night effect, and it's so powerful and so consistent that neuroscientists use it as a marker of how threat detection works in the brain. When you walk into a new room, your brain doesn't care that you're safe. It doesn't care that the door is locked and the hotel has a night clerk downstairs. Your amygdala, the part of your brain that processes fear, starts scanning. It's looking for the threat it doesn't know yet. This isn't happening consciously. You're not lying there thinking, maybe there's a tiger in the closet. Your ancient brain is running an older program. For millions of years, unfamiliar territory meant danger. A predator could be anywhere. Another tribe could be waiting. The ground beneath you might not be stable. Your brain hasn't updated that file. What happens next is neurologically fascinating. As you try to sleep, your brainstem, the most ancient part of your brain, the part you share with reptiles, keeps one hemisphere in a state called unihemispheric sleep. That means while one side of your brain tries to rest, the other side stays alert. It's literally half asleep. Dolphins do this. Ducks do this. They sleep with one brain hemisphere awake so predators can't sneak up. And so can you. Scientists at Brown University studying this phenomenon found that the anterior insula, a region tied to threat detection and bodily awareness, shows heightened activation when you sleep in a new place. Your brain is taking samples of the environment every few seconds, even while you're trying to drift off. It's cataloging the sounds. It's monitoring your heartbeat. It's checking the temperature. It's asking itself, is this safe? Is this safe? Is this safe? That's why a tiny sound, something you'd sleep through at home, jolts you awake in a hotel. Your vigilant brain has flagged it as novel. Novel equals potentially dangerous. Your eyes snap open. Your cortisol spikes. You're back to square one. But here's where it gets more interesting. The first night effect only lasts about 1 night. Maybe 2 if you're in a genuinely bizarre space. By the second night in the hotel, your brain has collected enough data about the environment. It's created a mental map. It knows that 11 p.m. is when the ice machine runs. It knows the air conditioning clicks on at midnight. It knows the distant traffic outside is not a threat. And suddenly, sleep comes easier. This adaptation mechanism was essential for your species. Humans are supremely adaptable. We live on every continent. We survive in rainforests and deserts and frozen tundras. We can build a home anywhere. But that adaptability requires a brain that can quickly assess whether a new place is friend or foe. The first night effect is the cost of that superpower. Your brain also doesn't sleep well in unfamiliar places because it hasn't resolved what researchers call sleep pressure in that location. Sleep pressure builds throughout the day as your brain accumulates adenosine, a neurotransmitter that makes you feel sleepy. But that pressure releases fully only when your brain feels the environmental threat is resolved. You can have intense sleep pressure, but if your brain is still categorizing your surroundings, that pressure doesn't translate into deep sleep. You lie there exhausted and wired simultaneously. There's one more layer to this. When you're in a familiar place, your default mode network, the part of your brain that handles self-reflection and mind-wandering, is relatively quiet when you sleep. But in an unfamiliar place, that network stays more active. Your brain is internally narrating, where am I? What happens if I fall asleep? What if something goes wrong? That internal monologue is the enemy of sleep. It's your conscious mind interfering with your body's attempt to shut down. Women, interestingly, show a stronger first night effect than men. This isn't because women are more anxious. Brain imaging studies show that women's threat detection networks activate more strongly in response to novel environments. Evolutionarily, this made sense. Female ancestors who were hypervigilant about new territory and the unknown dangers it might contain were more likely to survive and protect their offspring. That ancient algorithm is still running. You can't turn off this system. Sleep hygiene helps. Blackout curtains, white noise, the same pillow you use at home. These things reduce the novelty. They give your brain fewer new details to process, but they don't rewire your threat detection system. That system exists for a reason. It kept your ancestors alive when a mistake meant death. So the next time you're in a hotel and you can't sleep, you're not failing. You're succeeding at being human. Your brain is doing exactly what it's supposed to do. It's keeping you safe in unfamiliar territory by refusing to let you fully relax until it can confirm that nothing here wants to eat you. You might be exhausted tomorrow, but tonight, your 200,000-year-old security system is doing its job, even though the only real threat in that hotel room is the thought of how tired you're going to be.